Okay, let's just dive right into this explainer. Now, just to set the stage right off the bat, this summary we're about to go through was actually created using Gemini Notebook, but absolutely everything we're covering today is based entirely on actual, verified public sources. We are looking at Anthropic's brand new Claude Opus 5 release, and we're examining it through a highly specific, security-focused lens. So here is our agenda for today. We'll hit the Opus 5 baseline, offensive versus defensive capabilities, guardrails, cyber verification, and finally, enterprise deployment. Look, for our expert DevSecOps and architecture audience, we're completely skipping the marketing hype. Today is strictly about analyzing Opus 5's real capabilities, its intentional security limitations, and exactly how you can deploy the things safely in your own enterprise environments. All right, Section 1. Let's look at the Opus 5 baseline, specifically focusing on its performance and cost. To really grasp the defensive utility of Opus 5, we have to establish its baseline as Anthropic's newest frontier model, and the absolute crucial point here is the economics. Opus 5 comes in at exactly $5 per million input tokens and $25 per million output tokens. Why does this matter so much for security pipelines? Well, at this price point, you are getting intelligence that approaches the high-end Claude Fable 5, but literally at half the cost. It completely flips the math for running continuous, automated security analysis across massive codebases. And this capability leap is just massive. On the Frontier Bench evaluation for agentic coding, Opus 5 hits a new state-of-the-art score of 43.3%. That is more than double the performance of its direct predecessor, Opus 4.8. When you're trusting an AI to navigate complex legacy architecture or trace a vulnerability through dozens of files, that kind of jump in reasoning and reliability is a total game changer. Moving on to Section 2, offensive versus defensive features and the model's dual-use capabilities. This is honestly where the engineering of this model gets incredibly relevant for us. Based on OSS fuzz data from the system card, there is a stark contrast in its dual-use nature. On the defensive side, Opus 5 is highly effective at finding vulnerabilities. I mean, it is a powerhouse for root cause analysis. But offensively, it has been artificially nerfed when it comes to generating exploits for those exact same vulnerabilities. In fact, a direct quote from the source material confirms this. Opus 5 is, quote, substantially behind Mythos 5 on the exploitation of those vulnerabilities. Anthropic basically went out of their way to avoid giving Opus 5 cutting-edge training on offensive cybersecurity tasks. So, while it's fantastic at identifying a flaw in your code, it purposely trails behind models like Mythos 5 when it comes to actually executing a weaponized exploit against it. For defenders, what this really means is you get an incredibly persistent tool. Opus 5 is designed for agentic coding, which means it's capable of multi-day workflows. You can literally let it run overnight on a repository, bypassing just the surface symptoms to map out a bug's ripple effect across your legacy systems and actually patch the root architectural flaws. And you get all this deep analytical power without the inherent risk of unleashing an apex offensive weapon right inside your perimeter. Okay, Section 3. Let's talk about security guardrails and fallbacks and their underlying safety mechanisms. To enforce that defensive posture we just talked about, Opus 5 features hard-coded classifiers that outright block specific cyber activities. We're talking binary-based vulnerability scanning, active penetration testing, and exploit generation. Because these are tasks typically associated with malicious actors or aggressive red teaming, the model is strictly instructed to refuse them. But here's some really good news for your DevSecOps pipelines. The previous model, Fable 5, was so heavily restricted that it constantly blocked legitimate defensive work. Opus 5, on the other hand, represents an 85% reduction in classifier interventions. It's been dialed in so you can actually find vulnerabilities in your source code without constantly triggering those annoying false positive safety blocks. It is a way less frustrating experience for legitimate security engineers. Now, what happens if you do hit a guardrail? Well, Anthropic introduced a really smart fallback system on the API. First, your request gets flagged by the Opus 5 cyber classifier. Second, instead of throwing a hard error and just breaking your automation, the API automatically routes that request to the older Opus 4.8 model, which has different classifier thresholds. And finally, the developer is notified of the fallback. It's a brilliant way to keep your pipelines running smoothly without a hitch. Next up, Section 4, the Cyber Verification Program and Getting Advanced Access. I know some of you are probably wondering, But what if my enterprise actually needs to run automated penetration testing or exploit simulations? Well, that brings us to the CVP. For highly vetted security teams, Anthropic offers the Cyber Verification Program. If your organization qualifies, this initiative grants you access to a version of Opus 5 that completely bypasses those hard-coded guardrails. It lets advanced red teams utilize the model's full analytical weight for critical, offensive-leaning security research, all without compromising the safety of the public API.
Finally, Section 5, Enterprise Deployment, ZDR, and Cloud Support.
Let's look at the critical infrastructure angle here, how you can actually deploy this model securely within your existing cloud environments. Comparing previous policies, the high-end model Fable 5 required a controversial 30-day data retention period for safety and incident reviews. For a lot of enterprises, that was a massive deal breaker. Opus 5, however, allows for zero data retention, or ZDR. This means your proprietary code and vulnerability data aren't stored by the provider at all, which is an absolute necessity for strict enterprise data governance. And mapping out the cloud ecosystem, we're seeing excellent support. On AWS, Amazon Bedrock takes the lead by enabling ZDR by default, keeping your data safely locked within regional boundaries. Microsoft Foundry fully supports ZDR too, letting you wrap Opus 5 in your existing Azure native security and governance controls. And Google Cloud offers it with their shared model lineage quota and global endpoints. Basically, you have the flexibility to deploy right where your infrastructure already lives. Beyond just analyzing text-based code, Opus 5 brings some really advanced multimodal capabilities to the table. It features high-resolution vision, meaning it can read and reason over undocumented system architecture diagrams or complex network topology charts. Plus, it seamlessly integrates into environments like Microsoft 365 Copilot and even supports prompt caching, which is huge for reducing costs on long-running, repetitive security checks. So all of this data leaves us with a fascinating question to chew on. Does Opus 5's intentional nerfing, meaning its high ability to find bugs but heavily restricted ability to exploit them, truly make it the safest tool for your DevSecOps pipeline? Or does it just make it the most compliant option for corporate governance? It's a delicate balance of raw capability versus enforced safety. And frankly, it's what will define the future of enterprise AI. Well, I hope this explainer gave you a clear, structural understanding of exactly how Claude Opus 5 fits into the modern security landscape. For more deep dives into cloud, security, and AI insights just like this one, make absolutely sure you subscribe to the YouTube channel at AL Estrin. Thanks so much for joining me, and as always, keep building securely.